My name is Gry M. I work in a small consultancy called Expert Analytics, where we both help a lot of companies use open source code, and we also support open source by our boss letting us spend time on open source projects like part of our working time. So today I will talk about some useful open source tools for the power sector. I actually have a background in physics, and more specifically experimental nuclear physics, which is very different from the power sector. And funnily enough, my favorite PhD supervisor, he studied here at Chalmers, and he was the one who told me, no, you're not going to use MATLAB or anything close like that. You need to do, all the coding you do needs to be in something open, because we want to be able to share knowledge with other researchers, and then you have to be able to show people how you implemented it. And not just hand-wavingly, oh, it works like this. So he was like, no MATLAB or anything. I mean, no hate to MATLAB, but it's not open, right? So and it costs a lot. And he was like, we want people in third world countries to be able to look at what we did and understand it. So I had to learn to program well in things like C++. He also told me I might one day be happy to know how to program, because that will get me a paid job. That's true. But before coming into consultancy, I worked at the University of Oslo in basic research, and I helped my research group that I belong to start to share the code we used for analysis openly. I also pushed a lot for also sharing the data, because I think the two belong good together, open data and open software. In 2019, yes, I needed a job with my programming skills, and since then I have been working a lot with the power sector in Norway, and they hired me for my programming skills, but I think they kept me also because of my physics background, because I'm good at seeing how to model different types of systems in a good way. So data modeling, data flows, all this is also native to me. So we often talk about the power market. At least Norwegians are a little bit obsessed with power prices. And the interesting thing about the power market is that it is a market that physically demands that the demand and the supply have to match. Because it's difficult to store electricity, and if you do not match supply and demand, you get the wrong frequency, and our equipment does not like that. And in different areas of Europe, you have so-called transmission system operators, often called just TSOs. They make sure that the demand and supply actually match every second of the day. And if you go into Statnett in Norway, you have statnett.no, they have on their front page this gauger that shows how healthy is the power system. And to achieve this all over Europe, you need to take into account how the underlying transmission grid looks. And there are different kinds of bidding zones. For example, Norway is split into 5 bidding zones, Sweden I think 4 bidding zones, and these somewhat mimic the underlying bottlenecks in the grid. And every day, all the different markets shown on the map here, they are coupled through the day-ahead market using an algorithm called Euphemia. And it takes into account the constraints in the grid, and it takes into account how much demand for electricity people and companies are making in all these areas, and then it somehow figures out the price it should give to companies to be able to cover everything. And the way the market in Europe works is that the highest bid that is accepted sets the price for everybody. And the most rational thing in long term is to bid close to your actual short-term marginal cost of producing. If you are producing using water, if you're a hydropower plant producer, like many producers in Scandinavia are, then you need to think about how much can I get from my water today, and how valuable will it be maybe 3 months from now, or maybe even the next year. So the decision making is a bit complicated in many cases. Nuclear power plants in France, they make similar considerations. Should I power up now and spend more of the fuel and risk running out of fuel before the scheduled refueling cycle and things like that? But in the Nordics, we are highly dominated by hydro production. This is from one of my favorite websites, energycharts.info. They publish a collection of all the open data related to power markets in Europe. So you can see the bluish things here are in Norway, the water, and the greenish there is how much wind. And then there is an orange part which is a little bit like gas and other things. So hydro very often sets the price in Scandinavia, both in Norway and Sweden. Wind is also important, so you need a lot of weather-based input. So if you want to optimize, even if you are a tiny little hydropower plant producer, like this one shown here, you need to understand how much water is coming when and where. And you need to know a little bit about how that compares to the wind and the sun, what is happening in other bidding zones, and ideally you want to understand what is everybody else going to do in the market. So there are some interesting challenges. It's data intensive, you have a lot of time series. You need to understand the topology of the grid network, but also how the water topology works. And you also have a lot of less structured data, like the descriptions of all the power plants, how much they can produce, and so on. And if you want to study what is just going to happen tomorrow, you can do pretty well with the machine learning algorithm. But if you want to do a little bit of longer term planning, the best strategy as of today is to model all the players in the market. And then for each time step you want to optimize, you need to look at, should they produce or shouldn't they? And if they produce, how much should they produce? So for each and every power plant and each demand group you try to model, you have a lot of decision variables. So you get big optimization problems. And yes, big companies like Statkraft, for example, it's very important for them to model this correctly. But it's interesting to many other people. My boss was like, are people going to be interested in hearing you talk about this? I was like, yes, everybody should model the power market. If you want to build a data center, you want to know where you think the power prices will be good and a lot of power available, not just tomorrow, but for maybe 10 years, right? A very hot topic in Norway today is it a good idea to build nuclear power? I can't really tell without modeling the market long term. So, if we want to do a bit thorough modeling of the market, we want to collect a lot of time series data and also less structured data. Roughly, they can be grouped in two classes, like weather-related data and market data. And both of these, they come with some kind of geolocalization information that you need to handle. And then you need to make forecasts for how much water, how much wind, how much solar, how much demand, how much like fuel prices will cost, and how the power market is kind of structured today and how you believe it will change. And then you want to set up scenarios, because we don't know what the future is like, so you might want to see different scenarios. And then you need to do your optimization. And I just put one box here, but these problems can get big. And ideally, you want to be able to spin up many jobs on many computers, and you want to do it automatically. You don't want to have to configure manually too much, because life is short. So I think in society, electricity is very important, and it will continue to become even more important as we move from a fossil-based economy to more and more renewable-based. So it is so important for many different people to have insight into how the market works and what different decisions actually mean. So I have this vision that we need a really good open data set for the Nordics, and we need open tools that people can use for free and have insight into what is actually happening in optimization. And I would love it to be very user-friendly, so that you don't have to be a geek who knows how to compile C++23 and get it to work. You just want to press something, and ta-da, it works on my laptop. And I brought my Windows laptop because it works well with all projectors. But at home, I have my Manjaro laptop, and I love it, and it works very well on my Manjaro. I want people to have the Manjaro experience without having to run Manjaro. So that's kind of my mission. And now, how do we do that? So, there is this project or this open source toolbox called Shift Open Source. It started in Statkraft, and I believe Shift stands for Statkraft, Hydrology, something toolbox. And to begin with, it was just tools for figuring out this problem of when will the water come to my power plant and how much will I get. But it has been extended to help handle the geo information, so that you can automatically collect weather data for the right parts of the world, and orchestrate big runs where you have different models that need to communicate with each other and things like that. As of today, it's a little bit corporate kind of open source project. My boss said you would know what that means. So it's open, but the community isn't that big, and the main contributors are just a few people. But it is an ongoing work to make it more inclusive. So, what can you do with Shift? So I said that with hydrology, you can do things like create a grid in part of the map. And this is an example one of my colleagues created for a tiny little place called Krinsvatnet in the middle of Norway. And then you can set up your grid, and you can define the dots where you want to grab weather data, and you can say what kind of ground you have, because water cares about whether it's earth or mountains or water, and then you can easily configure your favorite settings for the model. I won't get into the details, but you can do that, and you can get out the details. You could run it just on your laptop, or if you want to make life difficult, there is a setup for automatically spinning up a lot of containers, where you have a lot of different components, where the most important ones are DTSS. So that stands for Distributed Time Series Storage. So it has, it can tell you what kind of time series you have, like some metadata, Geo information can be added, and you can also, it also has support for server-side computations. So you can give an expression and it will, for example, average many time series for you if you want. So you can move a lot of the workload to your server. And there is this green box called DRMs, or dreams it's often called. I can't remember what the letters stand for, but it's a sort of a compute node that can like tell you how the model is doing and if it finished or not, or if it failed, stuff like that. It's complicated, but it's very nice if you want to couple together many models for different geographies and stuff like that. So that would cover that upper part I'm circling, but you can rather easily do the same for all the different types of models you need for your input. But Shift is lacking a very important piece, and it has objects where you can store the whole topology in a C++ object that you can play with through Python. So it has a Python binding around the C++. So you can store the power market structure and everything, and you can connect to something that can optimize your problem and solve it. But it doesn't include the solver. It doesn't optimize for you. So that was my good idea, I feel, that there is this other big open source community called PyPSA, which is Python for Power System Analysis. They have done a great job. And just to be clear, I am a little bit guilty of some of the things in the Shift open source I have contributed. I have never contributed to PyPSA except cheering them on LinkedIn now and then, but I have used it, and I like it, and I have also read reports where people have used it to make simulations, and it looks quite good, at least for continental Europe. But the support for hydropower modeling has been a little bit, I think it could be better. So it would benefit from being combined with the Shift project. But it has everything Shift is lacking. So it has a lot of nice data pipelines that can automate the gathering of all this market data you need. It has optimization tools, and you can connect to both open source solvers and commercial solvers if you want to pay for that. And it has a quite large and active community, which is great. So I'm kind of hoping that by combining the two, we can create a better data set for the north of Europe. Yeah, I think I already said this, except that it's actually being used by several TSOs in Europe. So it is a quite good toolbox. But it is not, it started in Germany, I think, and Germany is heavily dominated by thermal producers. So you burn something, you get heat, and that produces electricity. And it doesn't work as well if it's a hydro-dominated system like we have in the Nordics. So if you combine the two, you can do this automatic setup for generating some forecasts, but you also get a good way to deal with the power market structure, in particularly the data you need for input. And you can use Shift to create nice little snapshots of the market structure you're doing the optimization for, so that you can easily keep track of the changes you do if you play around with your model and experiment, like we often want to do when we're modeling. It has the optimization part, but it's lacking the orchestration. Shift can orchestrate. So far, so good. But how is it going? Well, everything is great on my pre-ChatGPT Manjaro laptop, where I have a lot of RAM. I have 128 gigabytes, which now is like, wow, oh my god, I want to marry you, girl. But if I I go to some poor master student, I'm like, yeah, the model just needs 100 gigabytes of RAM. That's not going to happen. So I thought, you know, I would just, I was like, yeah, Ubuntu is popular. People like Ubuntu, and it's a bit more user-friendly, so I said to myself, I'll make it easy, I'm going to make a setup that runs on Ubuntu. I struggled so much, because when Shift, back in the days, Shift used to truly be cross-platform. It even worked on Windows. But as it evolved and started to include more and more things, and with the typical open source project structure where there's limited resources, it slowly reduced the support for different platforms, and currently you have to be team latest Fedora. I don't really like Fedora that much. So I have really, but I thought if it's going to be user-friendly, it has to work on different platforms, right? If you have a Ubuntu server, you can put it on, or I want to make a script that lets it run on the free credits the student got from Amazon, I think that should be possible too. So I have really struggled with silly things like the naming of packages that it depends upon, and it feels like being back in 2005 or something. But there is hope. So there is actually ongoing work to establish a Shift Foundation. It might get a new name, because it's not going to be a pure Statkraft project anymore, or Statkraft University of Oslo project anymore, so it might get a new name. But there are working groups now establishing like the, how is it called, like the rules for the foundation or something like that. And they are clever. They are working on also getting funding from the companies that are using Shift currently, so that we can actually pay someone to add things like support for Ubuntu or other popular distros. I hope to be able to give some good recommendations for what we can do to make it easy to create some scripts or an easy interface to use it, preferably so that you can just spin up some virtual machine and offload some of the computation to other cloud stuff. Because there are a lot of really cool tools being developed now by people in the power sector who aren't really programmers. But they would be, I mean, the tools look really good. You want to try them, but you don't want to put them somewhere where you have sensitive data, because you don't know how those tools were created, or you do, and that's your problem, right? So I think it's good. I want to create a setup where you can easily spin it up in a very isolated sandbox kind of way, and where people can play around and combine all these new tools to do something amazing and contribute to establishing an industry standard data set for the Nordics, so that all these people who have questions like, should we build wind plants, should we build nuclear power plants, they can model together with some people and figure it out themselves. And then the discussions will be a bit more interesting, because then you can like look at the actual underlying facts and discuss. So, if you are an open source developer and you think that your favorite distro is all you need to support, please reconsider. It's good to think about the user-friendliness, both for normal users who just want to use it, but also for the developers. On my top of the list for Shift specifically is I'm working on adding some adapters so that you can interface with Postgres and popular time series database, because Shift only has support, like it has built-in support for RocksDB, And that is not optimal for all types of workload, and it is also not the most user-friendly necessarily. So, that was my talk. Thank you.
Any questions?
Hi, thank you for this talk. I'm curious, is there also a link between your project and that LF Energy and the CPAF project, which is for the energy sector in a wider context?
No, not yet. But I think it would be very good for these different projects for the same sector to come together and work together, even though I see the need for people being allowed to have different focus. But yeah, no, not yet, as far as I know.
Hi, late for your lecture, so I might have missed something. I know an old professor from ABB that used to do deep analysis of different things. Lately in his 70s, he looked into the optimization model behind the European Union thing, you know, the norm pool and all of that. Has that any tangent to your work? You got production and price and so on.
Yeah. So yeah, of course there is a link, because if you want to model the market, what you do is so what PyPSA does is it has a model of the transmission grid, or the grid.
Yeah.
And that is used to somehow create what defines the limits of you use that to give you the markets where the actual prices are created. And they do something similar in Nordpol.
So this guy was actually doing for ABB in the 80s or 70s, was to do the first computerized model for grids.
Yeah, that's so cool.
In Fortran.
In Fortran.
And they required him to do an update in the early 2000s. And so he was concerned when he saw that the price model or optimization model was not in concert with what he knew about grids. And do you agree?
Yeah. So a lot of the commonly used tools in the power industry today are commercial tools that, as things might have changed recently, but as far as I understood, usually you do not really treat the grid properly when you do the optimization. You often just simplify and say you have a certain capacity to transfer between them, and that is not in keeping with how the prices are actually set, because that's not how it is done in Nordpol.
So now comes my cool question, because now I'm checking, I'm not all that stupid. So open source can actually make a difference in getting what everyone is complaining about, inefficiencies and stupid miscalculations in the grid. On a Swedish and European level, there is hope that open source could change it, because we can make it transparent and also, at least on the code level.
Yes, and I do think, I truly believe that having transparency both on the data side and the code level on such important decisions is crucial for Europe going forward, because decisions about the grid and where to build what kind of power nowadays depends on these very complicated tools. And you shouldn't make decisions by just looking out of the window. So I think it's so important for the public discourse that we have full transparency.
So if you didn't mention that before I entered the room, do please include this on the top in the next time you give this lecture.
Thank you for the
You probably don't work with predictable data sets. What I mean is you probably have data streams to collect data not only from the players, but also prices, everything. And so Shift have a backend for that, like an open source default backend that leverages performance in that case.
Yeah, so the DTSS were originally designed to handle data collection in a performant way, and it also has built in some caching capabilities so that you can keep in the cache the most frequently used data for each and every DTSS you set up. So it is performance oriented in that sense. It's not necessarily performance oriented in the sense of being easy for an analyst to understand how to use. So that is a different kind, and it's also it doesn't play well with tools for machine learning, which I think is a big challenge, because people nowadays, ideally, they want to combine these fundamental models that try to represent the market as true as possible with machine learning, for example, to replicate, how to say it, like irrational behavior in the market, for example, which is a thing. There is some speculation is happening, not all players are always doing what is rational in the long term, but they're trying to exploit short-term opportunities.
Thank you. Any more questions? Anyone else?
There's one last question there.
Sorry if I mixed up the projects now, so maybe this is a more of a pie TSA question, but how do you adhere to the fact that others in using the same model would act on the same decisions? You see what I mean? On the same information, like the marketplace or players all act on the same information, and that distorts the outcome. Is that stuff you need to handle, or is that something that PyPSA need to do?
I think that controversial opinion maybe, but I think that is already an issue, because at least in Norway, all the biggest producers, they all use the same models from Sintef, and I think the market is colored by that choice, and when you know that everybody else are using the same model, you would be stupid to use something else, because it doesn't matter what you, a tiny producer, is deciding to do if everybody else are following a certain logic, following a certain model. So I don't know if something like PyPSA anytime soon would be interesting for commercial players. So I think the commercial value of me being here is a bit low, maybe. Sorry to my boss if you're watching this now, but I think at some point new models will be needed, and then having an open one that can be evaluated both by commercial players and research institutions and independent players, I think that's very important.
Any more questions?
Lunch now.